In the beginning, there were no stars, no planets, no chemistry, no life, just a young, dark, and expanding universe, made almost entirely of two simple ingredients, hydrogen and helium. And yet, from that apparent simplicity, everything else would emerge. The iron in our blood, the calcium in our bones, the oxygen we breathe. It all began with the first stars. Stars so strange, so gigantic, and so fleeting that for decades they were considered almost mythical. This is the story of the universe's first lights and the human attempt to find them 13 billion years later. Let's look at the sun. To us, it seems eternal, but in cosmic terms, it is young. Our solar system was born about 5 billion years ago, when the universe was already nearly 2/3 its current age. That means that before the sun, entire generations of stars existed. They lived, died, and transformed the cosmos. Then an inevitable question arises. What were the first stars like? And what role did they play in the creation of everything we know? The Big Bang set the stage, but it didn't write the whole story. In the first minutes of the universe, only hydrogen and helium were born. All the other elements, carbon, nitrogen, oxygen, silicon, iron, did not exist. They were created later in the hearts of stars. There, through thermonuclear fusion, atomic nuclei joined together, releasing energy and making more complex matter. Each generation of stars enriched the universe a bit more, seeding space with the ingredients needed for planets, oceans, and life. In astronomy, those heavy elements are called metals, and their abundance tells a story. Stars are not all the same, they are different chapters of the same narrative. Stars like the Sun belong to population 1, rich in metals, frequently surrounded by planets. But when astronomers looked for older stars, they discovered something different. Stars with barely 1/100th of the Sun's heavy elements live mostly in the Milky Way's halo, an ancient region, a remnant of our galaxy's early days. They are old, but not enough, because even they contain metals. And that means one clear thing. They cannot be the first stars in the universe. The very first stars have a special name. Population 3. Stars born from absolutely pure material. Hydrogen, helium, nothing else. Zero metals. They formed when the universe had never seen a star before. There was no dust. There were no planets. There was no complex chemistry. Curiously, the name is inverse to time. Population 3 was the first. 2 came next, 1 much later, including the Sun. And the stars of the future, even richer in elements, might one day be called Population 0. For decades, Population 3 stars were a theoretical idea, necessary to explain the cosmos, but invisible. Until now, this is where the James Webb Space Telescope enters the scene. JWS doesn't just look far, it looks back in time. Each light spectrum is like a cosmic barcode. Each element leaves its unmistakable signature. Carbon, oxygen, iron, they can't hide. And when astronomers analyzed the light from an extremely distant galaxy, something left them breathless. There were no signs of heavy elements. None. Only hydrogen and helium. The best evidence so far that we were seeing the footprints of the universe's first stars. In today's universe, small stars are the most common. They live for trillions of years, longer than the current age of the cosmos. If the first stars had been small, they should still exist today. But there are any. That tells us something fundamental. The first stars were enormous, cosmic giants with masses hundreds of times greater than the sun's. They burned through their fuel in just a few million years, and they died young. and explosions that seeded the universe with new elements. The key lies in physics. When a star forms, its own light pushes away the gas trying to fall onto it. It's radiation pressure. In modern stars, metals increase the gas's opacity and limit the star's growth. But population 3 stars had no metals, nothing to slow down their brew. Thus, they could reach masses hundreds, maybe even 1,000 times that of the Sun. They were incredibly luminous, shining mostly in ultraviolet light. Here another challenge arises. Ultraviolet light doesn't reach us easily, but the universe is expanding. And as it expands, light stretches. Ultraviolet radiation from the first stars transforms into infrared, exactly the range JWST was designed for. And sometimes gravity helps. Nearby galaxy clusters act as gravitational lenses, magnifying the light from distant galaxies like a cosmic magnifying glass. Thanks to that combination, the impossible becomes observable. But science moves forward with caution. There is another possibility that this metal-free light comes from a primordial gas cloud and not from stars. The data are extraordinary, but not yet definitive. Confirmation will require more observations, more analysis, and more time. That is how science works. Not with immediate certainties, but with increasingly precise questions. The discovery was published in Astrophysical Journal Letters by researchers from the University of Toledo and Columbia University. But in the media, the story became fragmented. Some spoke of certainty, others of speculation. In a world saturated with information, understanding science requires a critical spirit and good sources. Because looking at the universe also implies knowing how we interpret what we see. If these observations are confirmed, we'll be seeing the dawn of the cosmos. The first stars, the architects of complexity, those ultimately responsible for our existence. We still do not have all the answers, but we are closer than ever. And while the James Webb continues to look into the past, humanity does what it has always done best: ask, doubt, and keep looking up.